Hey guys, these are your guided notes about the Pythagorean Theorem. Now these notes are pulled from a geometry class, so it starts out with a warm-up just reviewing solving by square roots. We're not going to do that, partially because you should have spent all day yesterday dealing with that. And let's just jump into what the Pythagorean Theorem is. This is this relationship that exists only in a right triangle. So in a right triangle, if you look at the sides, which means I'm going to call this side here that's across from this right angle, I'm going to call it little c because it's across from capital C. I'm going to call this side here little a because it's across from capital A. So I'm saying like it's between a B and a C and it's across from an A. That's what I mean when I say across from A. And lastly, I'll call this side little b because it's across from capital B. This side length thing, there's a relationship with it. So if I take side length A and square it, but I also take side length B and square it, it will always equal side length C squared. Always. It's this weird property that was discovered really long time ago that's really useful in real life. Like if you end up growing up and decide to go into carpentry or woodworking, I guarantee you're going to use this a squared plus b squared equals c squared to some capacity because it's real life useful. Now, when I say a and b, I want to point out what they're across from. A and b are these little bitty acute angles. They're not the right angle. C was the right angle. So this is called the hypotenuse. It's the longest side of a right triangle. It's always across from the right angle. A and B are neither of those things. They're not the biggest. They are not across from the right angle. So these are both just called a leg. So if you take a leg and you square it, plus the other leg squared, you will always end up setting it equal to the hypotenuse squared if you have a right triangle. So this squared relationship can be solved by square roots, which is what we're going to look at here, because in this right triangle, I'm missing one of my sides. Specifically x, if you look at where it's related, x starts here, x ends here. It starts at an acute angle, it ends at an acute angle, which means the only other angle is the one it's across from. It's across from the right angle. We are solving for this one, for the hypotenuse, which means I am looking for this term. I'm going to say the leg squared plus the leg squared equals that hypotenuse squared. In this problem, I'm going to use A and B as 5 and 12 because they're the legs. They are the sides that create the right angle. I'm going to have x be my hypotenuse because it's across from the right angle. So I can rewrite my Pythagorean theorem as the leg squared plus another leg squared is going to equal the hypotenuse squared. And we said yesterday we can solve this by squaring those numbers, simplifying it out. 5 squared is 25. 12 squared is 144. That's what x squared is going to get me. When I combine like terms, I'll get 169. And that actually is a perfect square. You might not have remembered it, but 169 is the same thing as 13 times 13. What I want to point out is really, really important yesterday to always have the plus or minus. As soon as you talk about a geometry problem, you're talking about an actual length. You have never once in your life stood negative 13 feet away from anything because we don't measure lengths with negative numbers. So algebraically, there's a plus or minus 13 here. When I go to say what x is, I'm just going to say it's 13 units long. And we don't need this approximate blank here. But the solving shouldn't be the issue. It's really the setup that always throws people for a loop. So be really careful. What are the legs? What is the hypotenuse each time? So that's what we're going to do for example 2. What are the legs? What is the hypotenuse? So the legs are the sides that create the right angle. My right angle's here. So one side of this right angle is x. One side of the right angle is 3. Those are the two sides that run into the right angle. Across from the right angle, the only side I haven't traced is the 6, which makes it the hypotenuse. The Pythagorean theorem says if you take the leg squared plus a leg squared, it has to equal the hypotenuse squared. So that's what I'm going to do. I'm going to take x squared, I'm going to add on 3 squared, and it has to equal that hypotenuse squared. And now we have a quadratic equation that we can solve. I'm going to start by simplifying. 3 times 3 is 9. 6 times 6 is 36. I need to get x by itself, so everybody's got to move away. You have to subtract first. So x squared is going to sit there for a little bit, and I'm going to do 36 minus 9, which is 27. Now 27 is not a perfect square, so I need to think what divides into 27. Well, 3 times 9, which gets me some more 3's. So when I solve by square roots, I'm not going to really think about the square root of 27. I'm going to think of the square root of 3 times 3 times 3. And as always, when you solve by square roots, you have two solutions. We're just going to chuck out the negative because I'm not going to have a negative leg length. Pairs make perfect squares. 3 times 3 is 9. Square root of 9 is 3. There's a leftover 3 who didn't pair up. So that means that leg, which I kind of skipped over, the leg was what I did not know in this problem. Its exact length is the positive 3 square root 3 units long. If I wanted the approximate solution, that's when I finally pick up a calculator. Let's see if I can get my calculator open. And I'm going to type in 3 square root 3. And my calculator tells me that's 5.196 blah, 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 blah. It says nearest tenth, so I'm going to say about 5.2 units. And then if I want the perimeter, notice it says exact perimeter. I don't need that decimal solution. Perimeter is when you add up all the sides. We said one of the sides was a 3. The hypotenuse was a 6. And we found that the missing side was 3 root 3. When we added radicals a couple lessons ago, we said they had to be like terms. I only see one thing with the radical, so he's not like anybody else. But these two are like terms. So I'm going to go ahead and say 3 plus 6 is 9. 3 root 3 is just 3 root 3. And if I don't want to round anything, that's the best perimeter we can get. But it all stems from this relationship of the legs and the hypotenuse. That's the important thing.